All right. The article that I am going to be talking about is called Immunoassay for Ethyl Glucuronide in Vitreous Humor, a new tool for postmortem diagnostics of alcohol use. And so this is an article by Juha Rainio and many others that was published in 2013. So upon reading this title of the article, I knew it was going to be something that interested me because of the idea of immunoassay, but also of alcohol use. But there were some words that I kind of wanted to make sure were clear before we even get into the article itself. So the first is immunoassay. So that is kind of the major topic I'm going to be talking about because this is a technique they're using to be able to determine alcohol use in bodies postmortem. So immunoassay is a forensic technique that can be used to basically use antibodies or antigens that are going to detect molecules based on some specificities and interactions with them. So you can kind of see a picture of what happens here in the top right. But the idea is these antibodies here are added to the well, and they're going to be specific to bind whatever you are looking for. And so in the case of this study, they would use antibodies that could bind this ethyl glucuronide. ETG is kind of what it's called for short. And so those antibodies are going to be able to bind that. Then you're going to add a kind of secondary antibody that's going to bind to what's already been bound. And so that's this red part here. And so that's just going to kind of increase the specificity. Generally, just the ETG is going to bind here. Nothing else would be able to. And then this second antibody is going to also bind to the ETG on the other side, just kind of trying to be more specified there. Finally, once you've done that, then you could add some kind of colorogenic enzyme. And the enzyme is going to attach and detect these extra antibodies that you added. And when it does, it will change color. And so the colorogenic enzyme will change the color of the well. And if the well changes color, you know that that antigen is present. So in this case, the ETG is present. So that's kind of a general overview of how immunoassay works. We're going to talk a little bit more later about what's good about it, the benefits kind of over some other techniques, and why it's good for this study in particular. Some other words that we wanted to look at were ETG. This is actually a kind of metabolite or substrate of ethanol, which is kind of the key component to alcohol. So generally, what's been happened in the past is that alcohol is detected via the ethanol that's in the body, so in serum, urine, tissues, hair. But a lot of times, a couple days after a body or somebody dies, the ethanol is harder to detect, or it's not super consistent with the results, whether it's kind of seeps into the tissues in the body or it gets eliminated in some way. And we'll talk a little bit later about some other things of why ETG might be better. So that's kind of where we're looking at there. The vitreous humor is part of the title as well, and that's just a piece of the eye right here. And so it's actually the kind of viscous gel that's in the middle of the eye, and it's kind of in the space between the lens, which is right here, and then the retina in the back of the eye. So it's just that gel in the space of the eye. So that's important to note that they're going to be using that in this study. And then post-mortem, in case you don't know that, it just kind of means after somebody dies. So we're talking about autopsies and things like that. So just some general background terms that are important to this study. So this research was kind of done for a lot of reasons. Obviously, deaths due to alcohol are kind of an issue in places. There's a lot of accidents that happen due to alcohol. Suicides happen due to alcohol, homicides. And then it also is related to diseases of like the liver, pancreas, and heart, and those can lead to death as well. The study specifically mentioned in Finland, which has a population of like 5.4 million. There have been 2,700 alcohol-related deaths in kind of a recent year. While in the U.S., and this was just kind of a side statistic, of a, like 320-ish million population, there have been about 88,000 alcohol-related deaths. And those are just ones that we can attribute right to alcohol. not necessarily ones that we don't know exactly the cause. So a lot of deaths, obviously, we want to be able to detect kind of what the issue, why somebody died. And so if it is alcohol, this kind of technique helps us with that. Some more reasons that this research is important is that, as we said before, excessive alcohol use, it's hard to detect. So background information for a subject that may have died is not always specific or reliable. So if somebody dies and the police go and ask their friends, were they a chronic alcohol user, their friends may not know, or they may just kind of say, oh, they have a couple drinks every week or whatever, when really they don't know that the person has a ton of drinks every week or something like that. So it's not always super reliable there. Another thing is that the blood alcohol content of bodies is often low, or sometimes even reported as negative when someone has died. So usually they either going to show a negative result, so that would mean like no alcohols in the blood, or like a low amount of alcohols in the blood. And this is just can be due to like absorbing alcohol into the surrounding tissues. Water recovered bodies could have diluted fluids, things like that. There's also false positives that can exist, and that could be due to bacterial decomposition of the body. And so sometimes when bacteria is going through the process to decompose the body, one of the byproducts of that bacteria is ethanol. And so sometimes that actually spikes the amount of alcohol that you may see. And so you might get a false positive there. It's also a lot of the fluids of the body are subject to contamination by bacteria and other things. So not always the best method there. This study found that the vitreous humor would be a better option for analysis because being a gel within the eye, it's pretty isolated from a lot of the blood and the urine as much. So it's a little bit easier to be able to check, and it's not potentially going to have as much contamination as some of the other places in the body. So general scope of this study is that it chose 58 individuals, so mostly males, but a handful of females as well. They mapped out the data on these people's alcohol use. And so they collected police and medical records so that they could have people in this study that both used and didn't use alcohol, so that they had kind of controls and could figure out if the information they were getting was really matching what was reported for these people. They did a few different things. They took blood samples from the femoral vein and they analyzed those using gas chromatography. Big thing there was just to kind of compare previously used methods like using blood samples with kind of their new method and kind of see what overlap and how accurate each one was. They also got serum specimens separated. They collected samples of vitreous humor, and they also recorded analysis of autopsies, and that kind of included like stature, weight of the body and liver, and then cause of death, just so they could have kind of those data points on each of the individuals, as well as the data they were going to collect from the vitreous humor. So then once they had some of their samples, they would use immunoassay. So a little background about immunoassay. It began in 1959. These two people on the right here are credited, Rosalind Yalow and Solomon Berson, with kind of starting the immunoassay technique. And of course, as most technologies have, it has improved over time. It was reported that in 2012, the commercial immunoassay industry made over $17 billion. So definitely is becoming a more popular technique. And again, we're going to get into the details of why it's more popular and what's good about it a little bit later here. But some applications that you could use immunoassay for would be finding thyroid stimulating hormone that can help kind of with hyperthyroidism, and then a C-reactive protein to assess for a risk of cardiovascular diseases or just kind of poor cardiovascular health. So being able to detect those proteins and hormones is pretty helpful with immunoassay.